So in this video we are going to draw this function e sub p of y mgy. Also we are going to deal with this potential energy 1/2 kx squared, that is a parabola, and we are going to prove the two basic things looking at the graph. The first thing that we are going to prove is that the average force is the negative of the slope in the graph e sub p of y. So you see the graph of e sub p of y, you see the slope, and you put minus the slope, and this is the force. Well, it's good, because from a graph of e sub p of y, you know what is the force at any point y, or at any point x. So the second thing that we are going to see is that if we give to the system a total energy E, let's say 100 joules, this 100 joules is shared between potential energy and kinetic energy. Maybe 60 of potential energy, maybe 40 of kinetic energy. Maybe the potential energy grow up to 80, so the kinetic energy has to decrease to 20 to be the total energy 10. So you will find that analyzing the graph of e sub p of y or e sub p of x, there exist return points, points that cannot go further than this point. So this is the two main things that we are going to see. So let's go to see the first thing in this case. E sub p of y equal mgy. So this is the graph of a rectilinear line with a slope ay, e sub p of y, ay. The slope is mg. This is the slope. Oh, so the force should be minus the slope, minus mg. This is the force. Oh, I found it. But why? Why this will work? Because, first of all, the slope, you know from what we have seen, that the slope is delta e sub p. This quantity, the slope between y1 and y2, is e sub p of y2 minus e sub p of y1. So it will be this quantity divided by this quantity, delta e sub p divided by delta y. So this is the slope. But we know that the force, that the work done is Fy by delta y, and the work done is minus the variation of the potential energy. From this we found that the force is minus the slope. So you know, if you see a graph like this, you see the slope, you say, ooh, the slope is very big, so minus the slope is the force. So the force is Fy equal minus mg, going down. From this graph, I can know what is the force. I leave you as an exercise to do the same thing with the graph of the force of the potential energy for the case of a oscillator of a spring. So in the case, homework, if e sub p of x equal 1/2 kx squared, so means e sub p of x equal 1/2 a squared is a parabola, okay? So the slope here is positive, and the slope between 2 points, x1 and x2, is also positive, so the force should be negative. So the force is pointing out in the minus direction. And the value of the force is the magnitude of the force is the magnitude of the slope. So it's a force that is negative, and the value is the slope of the curve. So F should be equal minus kx. So what is the slope? What is the homework? The homework is, let's say that you have an e sub p equal 50x squared, and I want you to find f of x. What is f of x? Okay, e sub p of x. This is the homework. What is the force that match with this potential function energy? And the second important thing that I said. Let's say that I have the graph of e sub p of x. So this is e sub p of x, e sub p of x. This is the graph of e sub p of x. It's an oscillator. It's a spring that has a mass, and the mass has energy, cinetic energy, and the total cinetic energy is the total mechanical energy is cinetic mass plus potential. So the total energy is cinetic plus 1/2 kx squared. So this is the total mechanical energy. So this is the point x1, and this point x1 have this energy, e sub p of x1. This point x2 have another energy, potential energy, bigger potential energy. If I move to the right, it's bigger the potential energy. So this is x2. As I said, the slope minus the slope is the force. Okay, now this is the second point that is interesting. Suppose that I give to the systems, I give this total energy. So it means that this is the total energy. This quantity is the total energy. This quantity is cinetic energy and potential energy. So if I'm here, this is the cinetic energy, and this is the potential energy, and this quantity is the cinetic energy, E sub k. And the sum is the total mechanical energy. If I'm here, this is the potential energy, and all this is the cinetic energy, because E sub k plus E sub p is the total energy. So if there is a conservation law, if the potential energy increase from x1 to x2, the cinetic energy decrease. So what I want to point to make you understand that these points are points of return. This point, let's say that we call minus a and plus a. You cannot go far away from minus a. You cannot go between minus a and plus a. The movement is in this region, between minus a and plus a. Why? Because if you try to go to this point, the potential energy, let's say this is the curve, okay, the potential energy will be all this quantity. So the total energy is this quantity. So it will correspond to a cinetic energy that is negative. This quantity will be the cinetic energy, negative, going down. So cannot happen because the cinetic energy is positive. So what I have proved you is that there is, if you have an oscillator, for example, you have 2 points of return. So your problem is now is what you have to do. Homework. What you have to do to increase from x equal plus minus a to x equal plus minus 2a. So I want that the oscillator goes farther away. What you have to do, what change you will have to make to the system in order to be possible to the system to oscillate between minus 2a, let's say this is minus 2a, and let's say this is 2a, let's say. So now I want the oscillator oscillated here. What you will have to do? And the answer is homework. That's all.